so we're going to let x be a positive integer that's not a perfect square. We're going to assume that we can write the square root of x as some fraction, and that y and z are relatively prime integers, a fancy way of saying that this is an irreducible fraction. So then what they do is they square both sides and say that x should equal y squared over z squared. But since x is supposed to be an integer, and z squared would have to be 1, and then x would end up being a perfect square, but x is not a perfect square by the beginning, so you get this little proof by contradiction. So x wasn't a perfect square, and so the square root of it can therefore not be a rational number. And so that's what we've proven. Where is it? The square root of any positive integer that is not a perfect square is irrational. So this is our guy. If you took the square root of any number that's not a perfect square, like the square root of 7 or the square root of 2 or something like that, it's going to be irrational. You're not going to be able to write it like a fraction. This proved it by contradiction. So this is our guy. We can look at the other ones and kind of just see that they don't make much sense. And you don't have to know the full proof to kind of be able to eliminate some of these. Is an algebraic number? No. No. The square root of any rational number is also a rational number? That's not even true, right? You can take a rational number like 7 over 2 is totally rational, but then when you take the square root of this, that's not rational, so it's not true. This last time, when the square of any real number is also real, that's true, but that's not what this thing is proving. We have square roots and stuff involved, and it's not what it's proving. So it's just they want you to be able to recognize this particular proof. It's a common proof that the square root of any positive integer that's not a perfect square is irrational. And I go over this proof and one similar in another video. So there you go.